Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Mimzal bin Muhammad Fathi. So my matric number is AA241412. So I take a course in DAM 23903 Fluid Mechanic. So my lecturer name is Puan Siti Mariam binti Basri. So semester I in semester 2 in 2025 until 2026. So today I will present about the hydraulic press, translating fluid mechanic into mechanical power. Okay, for the next, we go through to the introduction and core objective. So a machine utilizing confined hydraulic fluid to generate massive compressive force via Pascal law. So we can see generate generate exceptionally large pressing force with high mechanical efficiency. Second is drastically reduce the manual effort required for heavy duty material deformation. For the last is deliver exact, repeatable precision in complex manufacturing process. For this slide, show the main component of a hydraulic system. First is power generation. The hydraulic pump change mechanical energy into hydraulic energy. So next is fluid management. The reservoir store the hydraulic oil. The hydraulic fluid carries the pressure through the system, and the directional control valve control the flow and direction of the fluid. So for the last is work execution. So the hydraulic cylinder change the hydraulic pressure into movement to the work, so such as lifting or pushing heavy object. So the pump create pressure, the fluid transfer it, and the cylinder use it to produce motion. Okay, this slide explain about a Pascal law. So which the basic principle of a hydraulic system. So Pascal law state that when pressure is applied to a confined fluid, it is transmitted equally in all directions. This formula is P equal to F divided by A. So where P is pressure, F is force, and A is area. So this is why hydraulic system can multiply force the lift heavy object with only a small input force. So on this slide, I will explain how hydraulic system multiplies force using Pascal law. First, a force of 200 newtons is applied to the small piston, which has an area of 0.01 square meters. Using the pressure formula, pressure equal to force divided by area, so we get a P equal to 200 divided by 0.01. So the answer is 20,000 Pascal. According to Pascal law, this pressure is transmitted equally throughout the hydraulic fluid. Next, the pressure acts on the large piston, which has an area of 0.10 square meters, or 10 times larger than the small piston. To calculate the output force, we use force equal to pressure multiplied by area. So F 20,000 multiplied by 0.10. So the answer is 2,000 Newton. So this means that an input force of only 200 newtons produce an output force at 2,000 newtons, giving a 10 times force multiplication. So for this slide is hydrostatic pressure, which the pressure exerted by a fluid at rest due to gravity. In a hydraulic system, pressure is transmitted equally throughout the hydraulic fluid, allowing force to be transferred efficiently from one piston to another. The governing equation, the hydrostatic pressure is P equal to rho GH, where rho is the fluid density, G is the acceleration due to gravity, and H is the higher or height of the height or depth of the fluid. So therefore, hydrostatic pressure depend on the fluid density, gravity, and fluid depth. So this principle is essential in hydraulic system because it ensures pressure is transmitted effectively, enabling machines such as hydraulic jack, press, and excavator to operate efficiently. Now, for this slide, I will explain the concept of continuity and flow rate in fluid mechanics. So first, the flow rate is given by the equation. So we can see the equation is Q equal to AV. So where Q is the flow rate, A is the cross-sectional area of the pipe, and V is the fluid velocity. So this equation tells us how much hydraulic fluid flow through the system every second. So next, hydraulic fluid is considered incompressible, meaning its volume does not change when pressure is applied. Because of this, the same amount of fluid must flow through every section of the hydraulic system. This is described by the continuity equation A1 V1 equal to A2 V2. So as shown in the diagram, when the pipe becomes narrower, the cross-sectional area decreases. To maintain the same flow rate, the fluid velocity increase. So in conclusion, the continuity equation ensures a constant flow of hydraulic fluid throughout the system, allowing hydraulic components such as cylinder and piston to operate smoothly and efficiently. So, the first phase of the hydraulic system operation, which is the pressurization phase. So, for the first step is the process begin when the electric motor start rotating. This mechanical rotation drive the hydraulic pump. So for the second step is the hydraulic pump then draw hydraulic oil from the reservoir. At this stage, the oil is still at low pressure. So for the next step is as the pump rotates, it pressurizes the hydraulic oil, converting mechanical energy into hydraulic energy. So for the fourth step is finally the directional control valve direct the high pressure hydraulic oil to the hydraulic cylinder where it is ready to produce force and perform mechanical work. Next, I will explain the second phase, which is the execution and reset phase. So the step 5, the high pressure hydraulic oil enter the hydraulic cylinder and act uniformly on the large piston. Because the piston has a large surface area, it generates a high output force. For the sixth step is this force push the piston downward, transferring a large compressive force to the workpiece. This is the stage where the hydraulic system perform its actual work such as pressing, lifting or shaping material. The seventh step is after the operation is completed, the directional control valve change its position and redirects the hydraulic oil back to the reservoir. For the last step is finally the piston retract to its original position, making the hydraulic system ready for the next operating cycle. Okay, on this slide, I will explain how physics work in a hydraulic system. First, pump activation. The pump moves the hydraulic fluid through the system. The flow rate and continuity equation explain how the fluid keeps flowing smoothly. Second, fluid confinement. The fluid is inside a closed system, so the pressure is spread evenly. This follows Pascal law, where pressure equals force divided by area. Finally, cylinder extension. The pressure push the piston and create a larger force. This follows the equation force equal pressure times area, allowing the hydraulic system to lift or move heavy load. So in summary, the pump create flow, the fluid transfer pressure, and the cylinder change that pressure into force and motion. So this slide show the working principle of hydraulic system. First, a small input force is applied to the small piston. Next, the piston push the hydraulic fluid inside the closed system. So the pressure is then transmitted evenly throughout the fluid because of Pascal law. This pressure acts on the large piston, producing a much larger output force. In simple terms, a small force is changed into a bigger force, which allow hydraulic system to lift or move heavy object. For the next, I will explain how energy is converted in a hydraulic system. For stage 1 is mechanical energy. The electric motor or pump provide mechanical energy to move the hydraulic fluid. So for the second stage is hydraulic energy. So the pressurized hydraulic fluid carries the transfer the energy through the closed system. Okay, for the last stage is mechanical force. The hydraulic cylinder change the hydraulic energy back into mechanical force to lift or press heavy object. So the system convert mechanical energy into hydraulic energy and then back into mechanical force to do useful work. So this is for the last part is conclusion, so we can conclude about the engineering through fluid mechanics. So for the first is release fundamentally of Pascal law to achieve massive force multiplication. So for the next is governed strictly by pressure transmission, flow rate and continuity principle. For the third is delivers unparalleled force, precision and efficiency to model industry. For the last is essential to global manufacturing, automotive, construction and industrial recycling. So that's all for me. Thank you.